What if a spacecraft launched nearly half a century ago just discovered something in space that scientists cannot explain? Not near Earth, not even inside our solar system, but in the vast darkness between the stars. That's exactly why scientists and physicists like Michio Kaku are paying close attention to new signals coming from Voyager 1, the farthest human-made object ever sent into space. Voyager 1 was launched by NASA in 1977. At the time, no one expected this spacecraft to survive for decades, let alone travel beyond the edge of our solar system. But today, more than 45 years later, Voyager 1 is still sending data back to Earth from a place no spacecraft had ever explored before, a region scientists call interstellar space. To understand why this is so incredible, imagine throwing a bottle into the ocean and expecting it to send messages back to you from thousands of miles away, decades later. That's basically what Voyager 1 is doing. It is now over 15 billion miles from Earth, traveling through a mysterious region where the sun's influence begins to fade and the environment of the galaxy takes over. And recently, something strange happened. Voyager 1 began detecting unusual signals and measurements that didn't behave the way scientists expected. In fact, some of the data suggested that the environment beyond our solar system may be far more complex than anyone imagined. Physicists like Michio Kaku have described discoveries like this as a reminder that the universe still holds enormous mysteries. Because when humanity first launched Voyager 1, the mission was simple: explore planets like Jupiter and Saturn, capture images, and send information home. No one imagined the spacecraft would one day become humanity's first interstellar explorer. But now Voyager 1 has crossed a boundary called the heliopause, the invisible border where the solar wind from our sun finally collides with the particles of the galaxy. Beyond this boundary lies an environment that scientists had only theorized about, and Voyager 1 is now the only spacecraft studying it directly. The data it sends back travels across billions of miles of empty space before reaching Earth's giant radio antennas. And sometimes, those signals reveal something unexpected, something that forces scientists to rethink what they thought they knew about space. So, what exactly did Voyager 1 detect? What kind of discovery could surprise scientists after more than 4 decades of studying this spacecraft? To understand that, we first need to look at what Voyager 1 is actually traveling through right now, a region of space that may hold some of the biggest secrets in our galaxy. Right now, Voyager 1 is moving through a region of space that humans had never explored before 2012. This region is known as interstellar space. To understand what that means, imagine the sun creating a massive bubble around our solar system. This bubble, called the heliosphere, is formed by the solar wind, streams of charged particles constantly flowing outward from the sun. For billions of miles, this solar wind pushes against the material that fills our galaxy. Eventually, however, the sun's influence weakens. At a certain point, the pressure from interstellar space becomes stronger than the solar wind. That boundary is known as the heliopause. In 2012, Voyager 1 crossed that boundary and officially entered interstellar space. For the first time in human history, a spacecraft had left the protective bubble of our solar system. But scientists didn't know exactly what to expect on the other side. Would the environment suddenly change? Would the magnetic fields behave differently? Would there be unexpected radiation or cosmic particles? That's why Voyager 1 carries several instruments designed to measure things like magnetic fields, plasma waves, high-energy cosmic rays. And over the past few years, these instruments have detected something surprising. Instead of a smooth transition into interstellar space, Voyager 1 found strange disturbances in plasma waves, vibrations traveling through the thin gas that exists between stars. These waves revealed something fascinating. The space between stars is not empty. Instead, it is filled with extremely thin gas, magnetic fields, and charged particles drifting across the galaxy. And sometimes powerful events, like distant supernova explosions, can send shock waves through this medium. Voyager 1 has detected these shock waves as faint vibrations in interstellar plasma. But some of the signals coming from Voyager 1 showed patterns that scientists did not fully expect. The density of particles around the spacecraft seemed to increase dramatically compared to what earlier models predicted. This suggested that the region just outside the heliosphere may be more active and dynamic than scientists once believed. According to discussions among astrophysicists and comments from thinkers like Michio Kaku, discoveries like this remind us that the boundary between our solar system and the galaxy is not a simple line. It's more like a complex frontier where different cosmic forces collide. Solar wind from our star interacts with magnetic fields from the galaxy. Particles from distant stellar explosions travel through the region, and Voyager 1 is drifting right through the middle of it all. Every signal it sends back gives scientists a small glimpse into a part of the universe we had never measured before. But the most fascinating part of this story is what these discoveries might reveal about the larger structure of our galaxy. Because Voyager may first not just be exploring interstellar space. It may be helping scientists understand the true environment between stars for the first time. The fact that Voyager 1 is still working after more than 45 years is already one of the most extraordinary achievements in human engineering. But what it's discovering out there could be even more important. Every signal Voyager 1 sends back is helping scientists build the first real map of the environment beyond our solar system. Before Voyager reached interstellar space, most of our knowledge came from computer models and indirect observations. Now we have real measurements, and some of those measurements have already changed what scientists believed about the galaxy. For example, Voyager detected that the density of particles in interstellar space is higher than expected. This suggests the boundary around our solar system may be shaped differently than previously thought. Instead of a smooth bubble, the heliosphere might be distorted or compressed by forces from the galaxy itself. That means our solar system could be moving through regions of space with very different environments. Some areas might contain stronger magnetic fields. Others might contain more cosmic radiation. Understanding this environment is incredibly important because the space between stars is exactly where future human exploration will eventually travel. If humanity ever sends spacecraft to nearby stars, those missions will pass through the same interstellar medium that Voyager 1 is studying right now. In many ways, Voyager 1 is acting as our first scout for the journey to the stars. And its mission isn't over yet. Even though the spacecraft is running out of power, scientists believe it may continue transmitting data for several more years. Eventually, its instruments will shut down one by one, but the spacecraft itself will keep traveling forever. Long after its systems go silent, Voyager 1 will continue drifting through the Milky Way Galaxy. On board is something extraordinary, a golden record containing sounds and images from Earth, messages intended for any intelligent civilization that might one day encounter the spacecraft. It includes greetings in multiple languages, music from different cultures, and recordings of life on our planet. In a way, Voyager 1 is not just a spacecraft. It is a message in a bottle sent into the cosmic ocean, and the discoveries it makes along the way remind us of something profound. Even after decades of exploration, the universe still holds mysteries waiting to be uncovered. A spacecraft launched in 1977 is still teaching us new things about the galaxy, and that raises an incredible question. If Voyager 1 can reveal something unexpected after 45 years, imagine what the next generation of telescopes and spacecraft might discover. Because somewhere out there, beyond the edge of our solar system, the universe is still waiting to surprise us.